So let me get into the Blackboard shell. Okay, and inside of there's a folder that says Program Examples. So this is available to you to do if you want to go back and look at it. Look at Program Examples. These are from earlier semesters. But there's one, it's in the Functions folder. And the name of the program is Scope. So I'm going to download that one. I'll just load it up here in Dev C++. I'm going to save it over here in my in a folder that I have everything else for the class in. So I did this yesterday, but I'll do it again. Okay. All right, so what is this about? What are we going to talk about? You've heard me mention, I've touched on this briefly at different points, but I've never really just directly addressed it and we've never talked a lot about it. You've probably heard me mention things about global variables as opposed to local variables, stuff like that, right? So what does that mean? Well, basically the main thing we're talking about here is where we're declaring variables, okay? So if I declare a variable inside of main, so that's typically how I've done it, right? I've started my main function, and then there towards the beginning of the main function, I've had my variable declaration. So again, to make sure everybody knows what I'm talking about, a variable declaration is where you put the data type and then the name of the variable, right? You're reserving memory for a variable of a certain data type and giving it a name, an identifier name, right? So that's when it reserves the memory. Okay. So if you declare it inside of main, we say that variable is local to main. Only main knows about it, basically. And so if you have another function that needs to be able to access that, that's why we pass them in as parameters, right? And then the other type of way of declaring stuff, we could declare something as a global. Global means it's declared outside of all functions, or all blocks of code. And so, for example, on our circle program, we would declare the pi, right? We declared pi as a global constant, right? We didn't declare it inside of main. We stuck it up there before main. And so by doing that, we didn't have to pass pi in as a parameter to any of the functions, right? And so if you declare something globally, then all functions can access that. They can get to it, right? So that might lead you to think, well, why don't I just declare all my variables global instead of local to main? And then I don't have to pass any parameters to anything, right? Every function can access everything, every variable, because they're all global. But that's a bad practice to get into, and it goes back to that principle of least privilege that I've mentioned before. Right? Principle of least privilege basically says, don't give the power to somebody to do something that they don't need the power to do. Right? So if you have a function that only needs to access, that doesn't need to access certain variables, don't allow it to do that. So it's just good program design. So in general, what we say is you want to declare your variables locally. Global variables are bad, right? So don't do that. But we usually say that global constants are okay because they're declared as constants. They're not allowed to change because they're constant. If you declare a constant and you try to change the value of it later, you'll get an error because you declared it as a constant and you're not allowed to change it. So that's why we usually say it's okay for to have global constants. Okay. So that's what a local variable is and a global variable is. Okay. And so local just means it's declared inside of a block of code. Technically, a block of code is anything inside of curly brackets. Usually we consider a block of code like a function, but technically a block of code could be something smaller. It could be anything inside of curly brackets. Okay. So with that, let's take a look at this program. This program deals with scope and lifetime of variables. Okay. Sometimes I call this all my x's program, because you'll see there's the variable x that shows up over and over again. So we're going to have a whole bunch of variables named x, and we're going to have to keep track of which one is which and depending on where we are in the program. So in the comments, I have some explanation of what these concepts are and how they work. Okay. So scope basically means where in the program it is legal to access an identifier. Okay. So where in the program it's legal to access it. So basically scope means, can I get to it? Okay. That's basically what we're talking about here. Scope means, can I get to it? And the scope rules, if you can remember this rule, you can remember the scope rules. In the textbook, I think they have a longer explanation of the scope rules, but this is simplified. I think this is the main things that you have to remember, or the main things to remember here. Most local scope takes precedence over less local scope or global scope. Right? Most local scope takes precedence over less local or global scope. Okay, and I think that'll make more sense once we get into the program. Lifetime means the time in which an identifier has memory allocated or reserved for it. Okay? So lifetime basically means, does it exist? Okay? Does it have memory reserved? So when you declare a variable, it reserves memory, right? So we can store stuff in there. It's like, think of it like a variable as like a container where we can store something, right? But we don't want to reserve that forever, right? We might actually want to stop running our program and run some other application like Microsoft Word or a game or something like that. We don't want that memory to be tied up with our little C++ program forever. And so we want that memory to get deallocated or freed up at some point. And so here's how lifetime works. And these are the rules for automatic variables. This is how things are done by default, as opposed to static variables, and we'll take a look at that later. So for automatic variables, memory is allocated or reserved. Allocated is just a computer science-y word for reserved. So memory is allocated when a variable is declared. So when you declare a variable, it reserves memory for it. Okay? And that memory stays reserved until control reaches the end of the block of code in which it's declared. Okay? So remember, a block of code is technically curly brackets, right? So that memory stays reserved. If you declare a variable inside of main, that memory stays reserved until the end of main, right? If you have another function, a separate function, and you declare a variable inside of that function, that memory stays reserved until you reach the end of that function, and then it gets freed up by your operating system. Right? So we'll see in this program that these are related concepts, but they're different, right? So a variable can have lifetime, it can have memory reserved for it, but it might not have scope at that particular point in time. So it could be out of scope, but still have lifetime. All right. So what I'm going to do in this program, you probably wouldn't do this. Okay. It doesn't really make a whole lot of sense to do this, but it's good to go through and to understand exactly what's happening. All right. So I'm going to put this over here. Hold on a second. Put this over here, and then I'm going to have this loaded up to kind of keep track of some things. All right, so what do I have here? Well, I've got my main function, but then I've got some other functions too. Function 1, function 2, and function 3. They're all void functions. They don't accept any parameters or anything like that. Okay? And you see, I'll have several declarations. By the way, there's a difference between a declaration and an assignment statement, right? So like here, for example, in line 46, this is a declaration statement, right? It's got a data type in front of it. That declares a variable. But here in line 48, that's just an assignment. It's not declaring a new variable or anything like that. And of course, you can assign an initial value when you declare a variable as well. So just keep that in mind. So what do we have? So what I'm going to do is just kind of make some notes here to help me keep track of stuff. So first thing over here in line 42 is a variable declaration for a variable named x, right? That's outside of all functions, right? It's not inside of main or anything like that. So that one is global. It's declared outside of all functions. So I'm just going to make a note here. I'm going to say this is global. It's showing up. Sorry, let's start that again. I actually wrote it better than that. It just didn't show up. There you go. Global. All right. So I'm going to make a note here by writing x and then drawing a box. That just means that it has memory reserved for it, right? So there you go. And we put an initial value of 53 in there. So that's my global x. Okay. And so that's the first thing that happens. And then right after that, it starts with the main function. So whenever you run your program, it always starts with the main function there. And what's the first thing that happens in line 46? That's a new variable declaration, right? You can do that. You can declare another variable with the same name as long as it's not inside the same block of code. If you try to redeclare a variable inside the same block of code, you'll get an error on that. But as long as they're out in different blocks, then it won't give you an error. So this is my main function. And so I have an x there, and I initialize that to 0. Right? So now I have two variables named x. The one inside of main is local to main, right? Then I've got my global one. And so in line 48, when I say x is equal to 25, which one is it going to change? I have little hints on the side in the comments, right? So remember the scope rules? Most local scope takes precedence over less local and global scope. So at that point in time, the one with the most local scope is the one inside of main. So it's going to change the one with local scope. So it's going to change this one from 0 to 25. Has no effect on the global one, right? And so in line 50, when I say cout x, what's it going to output? Right, good. Let's see, this is my output. So it's going to output 25. Cool. And then in line 52, it's going to skip down to function 1. So skip down to function 1. Function 1, I'm going to take this word static out because I don't want that right now. Okay, so we're just talking about how things are normally. So we skip down to function 1, and what does function 1 do? Well, the first line is a variable declaration for x. Right? And so it declares a new x and assigns a value of 37 to it. So now I have 3 x's, right? 3 of them have lifetime. But at this point, only one of them has scope. And so in line 81, when I say cout x, which one is it going to output? The one with the most local scope, right? And so function 1, it'll output the one from function 1. So it outputs 37. Even though the others still have lifetime. And so in line 83, when I say x plus plus, which one is it going to change? The one with the, right, the most local scope one. So the one in function 1. So it changes this from 37 to 38. And then it will output, in line 84, it'll output 38. Good. And then that's the end of function 1. So at the end of function 1, the x inside of function 1 will reach the end of its lifetime. That's the end of the block of code in which it's declared. So this x goes away. It gets deallocated. So that memory's freed up. So I skip back to where I was inside of main. And just so happens the very next line, in line 53, does the same thing, right? It calls function 1 again. So I'm going to skip down to function 1. And this whole thing happens again. It's going to declare a new x and assign a value of 37 to it. It could be that same memory location that we just had for x. It might not be. The operating system's in charge of that. And that's fine. I don't want to be in charge of that much detail here, right? So it creates a new x and assigns the value of 37. And then line 81 is going to output 37 again. And then it increments that local x to 38 and does the same exact thing. Outputs 38. And then that's the end of function 1. Same thing happens. This one gets deallocated. So that's the end of the lifetime for that one. And then I skip back to where I was inside of main. And so the next thing inside of main says function 2, so it skips down to function 2. All right, and here's function 2. Function 2. So in function 2, it says cout x. Is there a local x here? There's no local x inside of function 2, right? The only other x that it knows about, that it can see, is the global one, right? It can't see the one inside of main unless it had been sent in as a parameter. Now, if I'd sent in an x as a parameter and I had it in the parameter list right here, that one would be a local variable. But there isn't one there. And so the only one that knows about is the global one. The only one it can see is the global one. And so in line 91 there, when I say cout x, it's going to come up here. This will be underneath the other ones. It will output 53, right? Because that's the global x. Right? Most local takes precedence over less local or global, but there's no locals. All right, and then in line, where am I? Down here. In line 92, when I say x is equal to 9, it's going to change the global x. So it'll change it from 53 to 9, like that. And then that's the end of function 2, but the global x lives on, right? It still has lifetime. It maintains its lifetime until the very end of the program. So I go from function 2, I skip back to where I was, and then the next thing back in main is a function called a function 3. So I skip down to function 3, and I do that. So here's function 3. Just kind of keeping track of stuff. Inside of function 3 in line 100, I say cout x. At that point in time, there are no local x's in function 3, right? There's nothing that's been declared inside of function 3 at that point. And so just like with function 2, the only one that knows about at that point is the global one. So it's going to output the global x, which is 9. Right? And then inside of function 3, the next statement is a variable declaration, right? Int x is equal to 45. So at that point, we're declaring a new x inside of function 3. So it begins its lifetime, and it has a value of 45. So now all of a sudden, this local x is going to take precedence over that global x, right? So in line 104, when I say cout x, it's going to output the one with the most local scope. So it will output 45. Right? So it kind of hides or masks off that global one, actually. And then that's the end of function 3. And so what happens then? Yeah, that's the end of the lifetime for this x, right? So it goes away. And I skip back to where I was inside of main. What was that? I was there. And then I've got this silly little if statement here in line 58. If 4 is less than 5, well, that's true, right? So it's going to go inside this if statement. And just to show that a block of code could be something other than a function, I have open and closed curly brackets. That's a block of code. And so inside of that block of code there, I decided to put a declaration for another x. So I'm just going to make a note here. This is the if statement. Block of code. And then inside of there, there's an x. So it reserves memory and assigns a value of 4444. And then inside of the if statement, when I say cout x, what's it going to output? 4444, right? The one with the most local scope. So most local scope, that's the one in the if statement, takes precedence over less local, this one, the 25, and global scope, the global one. So it outputs I'm just going to go back up here. Again, they're on separate lines. 4444. And then that's the end of that if statement. So that's the end of the lifetime for that guy. And then in line 66, it says cout x. Which one is it going to output? The one that's local domain. Yeah, so 25. Okay. And then that's it, right? And then that's the end of main. At the end of main, the one that's local domain reaches the end of its lifetime. So that one's gone. And then right after that, the one that's the global x, this guy reaches the end of its lifetime. So there's your output right there. So let's run it and see if we're correct. So I think that's it, right? 25, 37, 38, 37, 38, 53, 9, 45, 4444, and 25. Cool. Y'all see how that works? And again, I typically wouldn't do this, but hopefully that illustrates these concepts a little bit, scope and lifetime. So everybody could see that something could have lifetime but not have scope, right? Originally I had this line, I had this as static, right? So what was that about? So back over here in function 1, if I put the word static in front of the variable declaration, what that does, that will declare this variable x as a static variable. Whenever you put the word static in front of it, it will reserve the memory and initialize it, just like we did there the first time. But then it won't, at the end of the function, it won't reach the end of its lifetime. Its lifetime continues until the end of the program. So if I change that to static, if you remember what was going on at that point in time, I'd output 25, then it skipped down, and I output 37, and then 38, and then I went back to main and I called it again. The second time that I call it, it will still be sitting there with its value of 38. It was like this, right? Originally it was 37, so I outputted 37, then it became 38. And then at the end of the function, it's still going to be waiting there with the same value that it had, 38. when I call it the second time, it doesn't get reset to 37. It's still there as 38. So the second time I call it, it will output 38, and then it gets incremented to 39. Like that. There's your 37, 38, 38, and 39. In this course, we probably won't use static variables, but if anybody happens to take Programming Fundamentals 2 next semester, you'll see that word static come up again. It'll come up when we're talking about classes and creating your own user-defined classes, and a static variable in a class is something that'll be shared by all objects of the class. So anyway, we'll see that word again. So what do you think? Questions? And so again, a lot of what we do with programming, especially in our main courses that we're doing, like this course, Programming 2, and if you end up taking Programming 3 even, a lot of what we're doing is we're coming up with ways of storing data and manipulating data inside of memory locations. So it's important to understand how these concepts work, right? One of our next topics that we're going to talk about this semester are 1- and 2-dimensional arrays. So how are things stored inside of memory? Oh, okay, yeah. If you're wondering about the system pause, that's a DOS command actually, and it just pauses the screen. So I noticed earlier versions of the dev compiler, I think, when you'd run the program, it would show your output and then just disappear all of a sudden. But the newer versions have a built-in system pause. So like when you run it, it'll say that press any key to continue. Earlier versions didn't do that. They would just show things and disappear. So you could throw that system and then pause in there. It would pause the screen so you could see the results. And in fact, actually, it'll do the same thing there. So, but the system is like a C++ thing. You can throw any kind of DOS command on there, and it'll do it. So pause is actually a DOS command. So one cool thing that I've seen students do every once in a while in the past, you could actually have your program load up another program. Like suppose you had your output file or something like that, and you wanted to automatically open your output file whenever you ran the program. You could throw in something like, let's see if I have a text file in there. Loop notes. What is that? Oh, that's from. Suppose I wanted to automatically open that file. Suppose that was like my output file or whatever. Loop notes.txt. I could do something like this. Notepad.exe. Loop notes.txt. You can compile and run it. It'll automatically open up the notepad with that file in it. So that's kind of cool. But it can be any DOS command. DOS was something we had before Windows. But you can still get to the DOS prompt, right? So the command prompt. All right. I'm guessing the system probably, I doubt that it would work on Macs. I'm not sure what it would do on Macs. You could try it. All right, so that's that. Any questions about that? Scope and lifetime of variables. All right, I'm going to stop this, and then we'll do something else.